Yo, Chuck.
What the chuck is up, YouTube? In this video, I'm going to be going over Kadane's algorithm, which is a way to find the largest subarray, largest contiguous subarray in an array of numbers. It's really not that bad, but there is a trick to it, and once you're exposed to the trick, it becomes pretty easy. So, without further ado, let's get started. Alright, so the first thing I'm going to do is just make a function called Kadane's. I'm going to pass in an array of nums. I'm going to return those numbers, and then let's console log out the function call of Kadane's, and let's pass in some random array of numbers. So just, they can be positive, they can be negative, it doesn't matter. Something like that. Okay, now if I return this, I just get all those numbers back. So Kadane's solves the problem of what is the maximum subarray in an array of numbers, and it's worth mentioning that a subarray it could be a number like -1. It could be numbers -1 and 5. It could be -1, 5, and 3. It's all about being a contiguous subarray. So what's not a contiguous subarray would be something like -1 and -4, or 5 and -4 and 7. It must be contiguous. And our whole goal in this algorithm is to find the maximum value of a contiguous subarray. So the first thing I need to do is actually make a variable called max, and that is going to be my end result, which keeps track of the largest valued subarray I find. So initially, I can just set this equal to the first value in my nums array, which would be -1. So I'm going to do that. And then also, I need to make a variable called sum. And sum is just going to be the current sum of the current contiguous subarray I'm on. And each iteration of my loop that I'm going to run, I will compare sum to max. If sum is greater than max, I will set sum to be the new max. So initially, we can also set sum to index 0. All right, so now that I've established that, you can probably guess that we need to loop over the data. So I'm going to make a for loop, make a variable I, and set it equal to 1. The reason I'm setting it equal to 1 initially is because we've already initially said that our max is this -1 value at index 0. So we actually don't need to loop over this. And then I'm going to say, as long as I is less than nums.length, we can increment I. So the whole secret to this algorithm is this logic right here. I'm going to set sum equal to math.max, and I'm going to pass in array at I, or sum plus array at I. So what does this logic mean? And this is the trick of the algorithm that I was alluding to earlier. So you either set your sum equal to the current value, or you set your sum equal to the current value, the current sum plus the current value. So if initially we're saying our sum is -1, then we're going to compare -1 to +5. So -1 plus 5 equals 4. Okay, we could do that. That would be this logic right here, taking our current sum and adding our current value. Our current sum was -1. We add the current value of 5, we get 4. Okay, that might work. Or we can start anew and say, hey, this value right here is greater than 4, which it is. So we're actually just going to forget about this -1. Our new sum is 5. And we're just going to continue that logic, okay? So let me just walk the dog here. It might be helpful. Put in these numbers. 2, -4. Should fix that. -4, and then 7. So our sum is going to be -1 initially, right? And we're going to be on index 1. So our sum is -1. Then we're going to say, hey, we actually want to add that 5 because it'll give us a greater value. No, it won't actually. We can just start anew. And so Now we're just going to say our sum is starting at 5. We're going to increment I. We're going to be on index 2. Same logic. Now we're going to compare 5 and 3. If we add 3 to our sum, it'll make our sum 8. If we start anew, our sum would just be 3. So obviously we want to add those values. So I'm going to add those values and make 8. Now we increment I yet again. We're going to do a comparison of 3 and 2, or rather 8 and 2. If I add 8 to 2, that'll be a sum of 10. If I were to start anew, this logic right here, I'd have a sum of only 2. So again, we're going to want to add to our sum or our contiguous subarray, and we can increment I again. So that's basically the whole trick to this algorithm, is you're choosing to either start anew or add to your current sum. So each iteration also, you're going to compare your sum to your max. And the way you do that is very similar. You're going to use math.max, and then you're going to pass in the max value and the sum value. Okay, so now if I return max, let's see what happens here. Oh, I used array. This should be nums. Bad habits. Okay. We get 13, so it's saying the maximum. Well, let's make sure I put in my commas here. Let's try that again. Okay, 13. So it's saying the maximum subarray we have is 13. Let's see if we can find that. So we have 5 plus 3 is 8, plus 2 is 10, plus negative 4 is 6, and then plus 7, that would be 13. So that's where they're getting that from. Let's try to mess with it. What if I made this negative 3? Then where would our maximum contiguous subarray be? 7. It looks like this number of 7 is the greatest contiguous subarray. So like I was saying before, a subarray could just be one number, or it could be two numbers side by side, for instance. Let's try and do another one. Let's make this negative, and this positive, and this positive. 8. Where am I getting 8 from? Looks like 5. Yep, right here. These 4. You've got 5 plus negative 3 equals 2, plus 2 equals 4, plus 4 equals 8. So there you have it. That is Kadane's algorithm in a nutshell. It is very efficient. It has a time complexity of O of n, just O of n, linear time, because you're just looping over the data once, and that's all it takes. But it's really cool how you're using that logic of, should I start a new sum, or should I just add on to my current sum? And that is the trick of Kadane's algorithm. I hope you guys enjoyed this video and found it valuable. If you did, please like and subscribe. I will see you in the next one.